Hi everybody. Every once in a while I teach you a lesson that even I am very nervous about teaching to a video lesson. Um, these problems can be kind of tricky, and I normally get a lot of questions when students are working on these. So if you have some questions while you work through this lesson, write down those lessons or write down those questions, and let's talk about it at the beginning of class tomorrow. I'm also going to do a couple of examples at the beginning of class tomorrow, or at least I'll have a couple of examples up so we can talk about them if you want to talk about more examples. But anyway, uh, today's topic is simplifying radicals. And I have 5 examples that we're going to simplify today. I'd just like to share them with you. Make sure that it'd be awesome if you could do these 5 examples before you get to class tomorrow. But if not, try to have at least a basic idea so you have some questions you could ask about it. But these are the 5 problems we're going to do. I recommend trying them out either before I do them or during or after. It's your choice. Anyway, um, let's go ahead and get into the first example. I have the square root of 864. Now, I'm going to show you 2 different ways of simplifying this radical, and hopefully one of these 2 ways you will like. Well, when you're doing a square root, simplifying a square root, you first want to decide what numbers. We need to make a list, either in your head or on the paper. What numbers do you know the square root of? Well, I know the square root of 4, I know the square root of 9, I know the square root of 16, of 25, of 36, of 49, of 64, of 81. And I would say you should keep this list in your head all the way up to 144, all the way to 12 squared. It would be handy. Anyway, we look through this 864, and you are going to want to use a calculator on this. Problems on the quiz or test would be non-calculator problems, but it also wouldn't be a number as large as 864. But ultimately, you want to look through this list and decide what divides out of 864 that you know the square root of. Just knowing using my basic tricks, because 64 and 4 is divisible, I know that that 4 will divide out. But to lessen the amount of steps, you really want to divide out the biggest number possible. So if 144 divides out, that would be much smarter than dividing out of 4. Anyway, I'm going to test it out. I'm going to use my calculator here on the side. If I go 864 divided by 144, oh, I do. I get an even 6. 864 divided by 144 worked out to be 6. Yes, I am using the band calculator today. Excuse me. So it divides out. So 144 and root 6, and then the square root of 144 is 12. So you end up with 12 root 6. And that's it. And then at that point, there's nothing else on this list that divides out, so that you know that you're done. I said I was going to show this problem 1 way or 2 ways. I'm actually going to show it 3. You don't have to divide out the biggest number. You can just divide out any number you want. So let's say that you look at this and you quickly determine, because 4 divides out of 64, 4 must also divide out of 864. That's a true statement. 864 divided by 4 is 216. So this becomes square root of 4, square root of 4 times square root of 216. Well, let's see. I know if a 4 divides out of 16, a 4 would have to divide out of 216. So this becomes square root of 4. And if I divide this 216 by another 4, I get 54. So I have square root of 4 times square root of 4 times square root of 54. And then let's see. 4 does not divide out of 54, but 9 does. So this becomes square root of 4 times square root of 4 times square root of 9 times square root of 6, because 9 times 6 is 54. And then I'm finally at this square root of 6, and nothing divides out of 6. And then square root of 4 is 2, square root of 4 is 2, square root of 9 is 3, and a root 6. 2 times 2 times 3 is 12, so I get 12 root 6. So pulling out single numbers, small numbers works, but it's a lot more steps, and people sometimes make silly mistakes at that point. Okay, technique number 3. Technique 3 actually is a technique that I'm going to use later on in this lesson, so it's a good thing to know. You take your 864 and make yourself a prime factorization tree. If you are if you're just like good at dividing 2, this is a good technique. I know I can divide out a 2, and that would be 432. I can divide out another 2, and that would be 216. 216, that's even, so it's divisible by 2. 108, that's even, so it's divisible by 2. 54, that's even, so that's divisible by 2. 27, that's odd, so it's not, but it is divisible by 3. 3 and 9, and then 9 becomes 3 and 3. So another way of looking at square root of 864, square root of 864, according to my prime factorization tree, is the same thing as being, I have to cough, 2, 2, 2, 2, 2, that's 5 2's, so 2 to the 5 and 3 to the 3. Okay, now, remember how I said that there's a number in front of a square root, but it's imaginary? That number is a 2. So if I put a 2 here, you want to think, this new way of thinking here, think of this as a prison. And in this prison are a group of 5 2's. But they can escape this prison, but they can only escape 2 at a time. They have to hold hands to escape this prison. So, well, if they have to hold hands, that means of the 5 people in prison, 4 of them would be able to get out. So I'd break this up into the square root of 2 to the 4 times 2 to the 2. Oh, 2 to the 2. 4 plus 1 is 5, so this would actually be 2 to the 1. Now, of the 3 3's, 2 of them will be able to escape holding hands, so 3 to the 2, and then another 3. Okay, last but not least, at this point, the square root of 2 to the 4. Another way of thinking about that is, remember, square root is a half exponent, so the square root of 2 to the 4, that's the same thing as 2 to the 4 to the 1/2 power. And if we use our exponent rules, 4 times 1/2 is 2, this becomes 2 squared. So the square root of 2 to the 4th is 2 squared. The square root of 2 to the 1, I'm going to rewrite this, it's not good form yet. The square root of 2 to the 4th is 2 squared. And at the same time, the square root of 3 squared, so the square root of 3 squared, that's the same thing as 3 squared to the 1/2, so you end up with 3, just 3 to the 1. So it's 2 to the 2 times 3 to the 1, and then what's left on the inside is this single 2 and this single 3. Then ultimately, 2 squared is 4, 4 times 3 is 12, and 2 times 3 is 6, so you end up with 12 root 6. This technique might be a little confusing to look at right now, but this is the technique we're going to have to use with variables later on in my lesson. So, all right, that was example 1, square root of 864. Example 2, let's move into cube roots. Let's say I had cube root of 1,600. So much like square roots, you first want to think of what are the numbers that you know the cube root of. And that's cube list. 2 cubed, that's 8. So the cube root of 8 is 2. 3 cubed, 3 times 3 times 3, that's 27. 4 times 4 times 4 is 64. 5 times 5 times 5, 125. 6 times 6 is 36, times another 6 is 216. 7 times 7 times 7, 343. This is the list of cube numbers I'm requiring you. Well, not requiring. Yeah, requiring. Well, these are the ones that could show up on a quiz or a test. Anyway, what divides out of this number that we know the cube root of? Well, I know that an 8 divides out of 1600, and that would be 200 times. So I could break this into cube root of 8 times cube root of 200. And I know another 8 divides out of 200, so this would become cube root 8 times cube root 8 times 25 divided, or 200 divided by 8 is 25, so cube root 25. Now nothing on this list divides out of 25, so we're done with our simplifying. Square root of 8 is, or cube root of 8 is 2, cube root of 8 is 2, cube root of 25 cannot be simplified. 2 times 2 is 4, so you have 4 times the cube root of 25. Alright, that's technique 1. Technique 2, using the prime factorization. 2 divides out of, actually let's divide out of 4. 4 divides out of 1600 400 times. That 4 can become a 2 and a 2. The 400, that can become a 4 and a 100. This 4 becomes a 2 and a 2. This 100 could become a 10 and a 10. And then those 10s would both become a 2 and a 5. So at the end of the day, cube root of 1600 is equivalent to the cube root of 1, 2, 3, 4, 5, 6 2s, so 2 to the 6th, and 5 to the 2. Now, like I said in the previous problem, think of this as a prison, but this time it's a higher security prison. So it's not a square root where they can escape in teams of 2. It's a cube root where they can only escape in groups of 3. So if you have 6 2s hanging out in there, well, they can all escape. And if you think about the cube root of 2 to the 6th, that's the same thing as 2 to the 6th to the 1/3 power. 6 times 1/3 is 2. Or another way of thinking about it, 6 divided by 3 is 2. So you end up with 2 squared. The 2 5s that are in there, they're out of luck because there's only 2 of them. They cannot all hold hands together and escape, so they're stuck on the inside. 2 squared is 4. 5 squared is 25. So I have 4 times the cube root of 25. Alright students, I'm going to turn this lesson into a 2-parter tonight. I cannot breathe right now, so I need to go get some water. And I haven't even gotten to the hard examples yet. So I'm going to take a quick break, and once I get back, I'm going to do examples 3, 4, and 5. What happens when we have variables? Let's get some Big Elliot for the end of part 1. And whoop. Alright everybody, see you soon. Bye.